Right, this is Jennifer Lazarus, thesis presentation, July 20th. Go ahead, Jennifer.
Okay, so my thesis is over the topic of algebraic operations of polynomials and polynomial coding. And so we'll go into, first, we start off with an in-depth discussion of algebraic operations of polynomials. So we start off at the very beginning with an example that shows the relevance of polynomials and finding solutions to real-world problems.
Tell me where I should go.
Oh, okay. So right here.
Okay.
I guess. Yeah. We don't need to read the intro. It's just kind of explaining everything, I think.
Right.
So we can go down some more.
Did you want to give some background first?
Some background.
What this is and what the purpose of this whole thing was, and
Yes. Okay, so this was to get into I can hear myself. Okay, this was to get into polynomial coding. We wanted an in-depth background of polynomials and their algebraic operations. We start very basic with an example of using polynomials and how it's relevant in the real world. And then we quickly get into just the basic algebraic operations, adding, subtracting, multiplying. We don't get into dividing quite yet because we have to develop a little more background there. And we also bring it, I guess, we also present it in a way that it's, I guess, familiar or approachable to most students that have background in mathematics, just at least a basic background, starting off, at the high school level and quickly moving up into the college level. So we do show the operations. We also show it in summation notation, because that is something that when you use computers, it's with summation. And then after that, we get into discussions of rings and, well, groups first, because and then we get into the discussion of rings and special type of rings, fields, and discussing. Then we discuss polynomial division. You got the Euclidean algorithm, finding the GCD, and we end this chapter with a discussion of extension fields and algebraic closure, and those have application in polynomial codes. We'll get into the section on polynomial codes where we learn how to generate a polynomial. Generate a code from a generator polynomial, and there's special type of polynomials that are more efficient, I guess, in encoding and decoding. I think the chapter, it's not all the way complete, but later on there'll be more discussion on, what makes a good polynomial, and we're basically building the foundation for it in that part of the chapter. That's kind of the sequence of how it goes. Anyway, so we'll talk more about that as we, I guess, scroll through to the polynomial code chapter. But so on this chapter here, this is the real world example we were talking about, and it was just basically with two vehicles moving along a road. And so we showed how it could have application in adding the polynomials or subtracting them. Like if you subtract one from the other, you can find the distance or the relative distance. And I can't scroll here. You might want to scroll down.
You can't scroll. You have to let me scroll. Just tell me when to stop.
Okay. You can, I guess, stop here. And then we also wanted to show an example where there is polynomial multiplication. So if you have two vehicles moving towards each other and they're centered at the origin, you can actually create a right triangle. If you wanted to draw out how far away they are from each other, and use the Pythagorean theorem. To use the Pythagorean theorem, you'd have to, or to solve it, you'd have to use the multiplication. So it kind of covered the basic arithmetic that you would have with polynomials. And that's just a nice little intro to show the relevance of it. And it's pretty put in a way that it's very understandable to most students. And that's what we want, because this is going to be a textbook. You don't want students to just be reading theorems and not really understand, and you want them to know what they're being applied for and be able to do it. So that's, if you want to scroll down more. Do you have any questions? I thought there would be questions too. Are those at the end?
No, not so far.
Yeah, Dr. Hamilton, feel free to jump in anytime. I think it helps. It will help Jennifer to kind of, focus her comments on what you might be more interested in than just kind of saying things general.
Okay.
Yeah. And then right here, you can stop right here. Whenever we were looking at the times that the cars were like a certain distance apart, I think it was 500 meters apart, we had four routes, but only two of those were real routes. One when they're going towards each other, and then when they've passed each other and they're 500. And then the other two are going to be complex routes, and that, that'll have application later when we talk about extension fields and closure and stuff. Certain, if you have a field and the root is not in the field, then it's not algebraically closed. So here you've got real coefficients. So these are a polynomial with real coefficients, but the roots, not all of them are real. So this is kind of, since it's at the beginning, we don't explain it here. I guess maybe we could, I don't know if Dr. Thron wants to add it in and talk about it later after we've discussed it at the very end of the chapter. Going back to it. Let's see. I guess we can scroll down some more.
Okay. Right.
Well, I do have a question here.
Right.
Is there a history of the polynomials that you might want to add to the intro?
To the intro, there's some more background at the end. To some of it that Dr. Thron added at the very end. But we could, I guess. So you think there should be like a little more of a preliminary before starting with the examples?
Yeah, because when I was reading through it, like you said, I saw it at the end, but just for the readability of it, it would have been nice to be in the front so I can know the intro and the background prior to getting into the other aspects of it.
Mm-hmm.
Okay. I'll make a note of that and see what I can...
If that's not a big
You mean
change.
historical comment, something like that?
Yes.
Okay.
Yes, sir.
Right. Okay.
When did they start looking at polynomials? Okay, so let me write that down. I've got my paper copy here. Okay, I can do that. Okay, so we can go back down. Dr. Thron.
Okay. Just tell me when to stop.
Okay, right here, I guess. Okay, this is just the arithmetic. We're just making sure everybody has that background, knows how to add, subtract, and multiply. And we do highlight that it's done with the coefficients, because that's really what we're getting into. The coefficients define what type of polynomial it is, and all the properties that it's going to have. The coefficients are what matter. Let me see what else there is here. Okay, and then also we bring up that we're going to be talking about more, when we say more exotic types of polynomials with coefficients and something like modular coefficients or matrix coefficients, those type of things. That's something that's going to be new to the students that are reading this. So I guess we can go down. Okay, this is all just basic. We can really scroll through this unless there's something you want to add or think. I think, well, as it says right there, review, it is a review.
Mhm.
Let's see.
Let me make this a little bit smaller. I
Here.
think that it's probably.
Hello?
Yeah, hi, Minnie.
Hi, how are you?
Yeah, I'm
Dr.
fine.
Thon.
Good, thank you.
Yeah.
Am I late? I'm sorry, I forgot.
Hello, Minnie. This is
Yeah.
Jennifer. How are you?
Yeah,
Hi, very good, thank you.
it's okay. We were all late, but I actually
Okay.
I recorded the first part, so let me stop
Okay,
record. Let me stop recording. I better figure out
okay.
what's the right button to stop recording on. All right, let's see. Maybe it's F12, F10.
Didn't it just
Well,
stop?
no, it didn't stop. It's because it's red. It's still recording.
Oh.
Let me see. I'm having the same button disease that you were having, or the buttons that are supposed to be here are not here. So let's try. Here, let me just look for this. Sorry, I don't want to lose this recording. Uh, 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 Okay, let's see. Stop. No, stop recording says, or maybe it's escape.